to our workshop for this month, which is Cubicle's TRB frequently asked question, where I believe many of you have been long waiting for this topic, because we all know that TRB is much more complicated, or should I say much more hard to understand comparing to TS, because there's, like I said, rebar. Rebar itself is very complicated to understand time to time. And in terms of the calculation rules, also it's a little bit hard to actually do some adjustment based on the needs we want. So before I begin today's workshop, let's give the others maybe another 5 more minutes for them to join. And with that said, I will begin my workshop topic at 3:05 sharp. So if you find out that your colleagues or your friends haven't joined in yet, feel free to give them a notice saying that we will begin our workshop shortly. So while we wait for the others, I'll give you all a little bit of idea on what I will be touching on today. So basically, the topics that I'm touching on today are mostly on the frequently asked question, which is those minor details that users tend to neglect or not too sure that we actually have such function. So in today's topic, we will touch all of it. So let's give them the additional little bit more time. So we are beginning in 3:05 sharp. Thank you. Once again, welcome to our Cubicle's workshop, which is frequently asked question on TRBC software. All right. So before I begin my workshop today, let me do a self-introduction of who am I. So basically, my name is Chester C. So I'm actually a service consultant in Global Software Sdn Bhd. So my task is mainly provide training, project guidance, and technical support. So some of you may know me. And I graduated with a degree holder of quantity surveying from Taylor University. If you have any inquiries, feel free to email us at service-mine@global.golden.com. And if you have any technical queries you need assistance, feel free to contact us at committee.golden.com, which I will touch on later on. Because some of you may not know what does this actually stands for, because this is a newly introduced platform to the market this year, basically. So in today's topic, we will be touching on 4 chapters, which is commonly faced, or should I say commonly modeled out in the construction industry, which is those column, beam, wall, and slab. Basically, if you do a model, you require to have all 4 elements as shown here. It's a must. All right. So in chapter 1, we'll talk about columns. So on the first thing I'm going to touch on is this lab 1 versus lab 2. Now, in the construction industry, or should I say, when it comes down to modeling in TRB, some of you may adjust the lab value in attribute editor, but somehow it does not actually reflect the value that you have set in attribute editor. So case number 1 is this. Assuming the lab value you want it to be 40D, and then your upper column, which is your upper floor column, is 12 millimeter, and then your bottom one is actually 10 millimeter. Your bottom one, assuming is your current floor column in bar, which is 10 millimeter, and somehow 40 times 12 when you set in attribute editor. When you set attribute editor is 40D, am I right? But then again, somehow in terms of the edit rebar, they actually calculated 40 times 12. Whereas you actually want 40 times 10. What is the reason? Basically, it's this lab 1 versus lab 2. So if you realize that your lab value actually 40 times 12, as we see here, is actually by default is lab 1. It will actually follow the lab value you have set on the floor above. Not the current floor, but the floor above. So if you want your calculation in terms of your rebar to follow the current floor lab value, then you need to switch this to lab 2. You need to switch this to lab 2. So again, I repeat, basically, normally if you set your attribute in your attribute editor in terms of the lab value, like for example 40D, it did not reflect in your edit rebar. Why? It's because of this lab 1, lab 2. If by default it's actually lab 1, so your lab value will actually follow the floor above. You will not follow your current floor. Unless you switch it to lab 2, then only you will follow your current floor lab value. This just doesn't limit to your column element. It actually affects all vertical elements such as wall. So I advise strongly, when you start your model, make sure you switch this rule first. This is like the go-to rule that you must adjust, which is switch from lab 1 to lab 2. So again, normally our user will always ask us this, why our lab value never actually reflect. I change in the floor settings, my attribute editor, mainly is due to this. So once you set lab 1 to lab 2, you recalculate your column, you will actually reflect the lab value that you have adjusted in attribute editor. So next, double layer rebar. So what does this double layer rebar actually stands for? Something like this, basically. So when do you actually face a scenario such as this? When you have a very big column, it requires to have double layer rebar, which is all the rebar is labeled in blue color. That is your second layer of rebar. So normally in the construction industry, you normally will face this kind of column when you have a very big column and it requires double layer rebar, or you have a small column, but then again you need additional strength. So therefore, engineer actually add in another additional layer of rebar. So normally user will ask me, can our software actually model this? The answer is yes. So basically, you need to do such adjustment in edit session. So under edit session, you can select special method as per here. Edit session, in your edit session, select special method. And under our special method, we have 5 types where you can actually utilize that 5 options one of it basically to actually border out this double layer rebar. But I strongly suggest you all to use scale, because scale is the most efficient and most straightforward method to actually capture this double layer rebar. So again, the step will be quite simple. Edit session, special method, scale. So this is a short clip that I recorded, and you all can refer to this clip on how can we actually capture double layer rebar. So first you proceed to special method. Click on it, there's all the 5 types, but first adjust the bar, which bar size you want to use. So I adjust the rebar info, then I press scale, and once I done scale, I highlight all the bars, and then I can begin doing my double layer rebar. But of course, you can come here to actually key in. This is what we call dynamic input. You can actually key the value in terms of the distance between your original layer rebar, how far you want your second layer rebar to portray from. So you can actually key in the value here to indicate how far you want your first layer and your second layer, how far you want it between the distance between your first layer and your second layer rebar. So this is what we call dynamic input. So you can key in the value, and with that said, you're able to generate your second layer rebar. So again, edit session, special method, adjust the rebar info, scale, highlight all the bars, right click, and then you can key in the distance in your dynamic input. And with that said, you're able to generate your second layer rebar. So next, column stump main bar, unable to generate. So there's a case study I bring up. Under foundation floor, user have keyed in the rebar details in attribute editor, but after calculate the model, somehow the software only captured links. Why? As per this diagram, this drawing, as you can see here, this is my foundation floor, but it only captured my links. It only captured my links. Where is my main bar? Now, how do we actually solve this issue? But before this, normally user will ask this question: why won't I actually capture my foundation element in this project? So normally in the construction industry, some developer actually sub up, or some contractor actually sub the foundation element to another contractor or another subcon. So therefore, they don't actually think that required to actually go and model the foundation element. So therefore, in their model creation, they just ignore the foundation element. They just directly draw the column stump and any element that is parked under work above floor. So how can we actually solve this particular issue? Basically, is this. In foundation floor, in order to actually generate the main bar, right, you actually require to capture a foundation. So in terms of the foundation element, normally I would recommend you all to use rough foundation element. But then again, if you ask me, other than rough foundation element, can I use pile cap? The answer is yes. But then again, you need to point one by one the pile cap below the column, which is very time consuming. So therefore, I always recommend you all to use rough foundation element to draw a big piece of rough foundation directly under the column, and with that said, it will generate the column main bar for you. So with that said, Chester, if I actually go and model another foundation, will it affect my quantity? In TRB, if you don't put in any rebar info onto your rough foundation, there is no quantity at all. There is no quantity at all. So you don't have to worry about that. But of course, if you model it from TS, then yes, it will actually generate out the quantity. So depending on which software you actually start with. So if in terms of you start with TRB, then make sure you draw the foundation element directly under your column stump. Then once you migrate, or should I say import export your TRB model to your TS, just make sure you delete off your rough foundation will do. So if you start off with TS, you just ignore the foundation element. You don't have to model it. Once you go into TRB, just make sure you draw it. And with that said, you're able to capture your main bar in foundation floor. So this is a short clip how to do so. So by default, as you can see here, it only generates out my links only. So let me show you the 3D view. The 3D view on this column. As you can see here, in this 3D view, you can only realize this. There's only links. But then again, the funny thing is this. I already keyed the all main bar information, but yet it did not generate out it. Why? So let us go to our foundation floor. Under my foundation, I will select my rough element, my rough foundation element. So with that said, I will proceed creating one, and then I'll draw a big piece of rough foundation directly under my column, and you will see something different. So once I draw a big piece of rough foundation element under my column style, I recalculate my column. Make sure you recalculate your column. So you recalculate your column. Once you're done, now you see the main bar is produced. So remember this. In foundation floor, without foundation element, your column style will not generate you main bar. You will not generate you main bar. You only generate you links. So make sure you draw out your foundation element, then your column style will have main bar. Okay. So next, foundation starter bar. In our software, we call it as door bar, but in actual practice, it's actually starter bar. So in our software, in terms of how we capture starter bar, there is 3 types, as you can see here: A, B, and C, which you can actually adjust it in your calculation rules, basically which type based on your general notes, depending on which design that is designed by your engineer. So we provide you the flexibility on how you want to actually capture your door bar / starter bar. So option number 1, left at foundation top. So your starter bar is from foundation until this down. That's all. From here all the way here. Whereas the second one, type B, left at foundation floor top. So basically your starter bar will go all the way to your ground floor. And then the third one is where your starter bar and your column style main bar is separated. So which means as per C, starter bar is from foundation until stump, and then main bar will be categorized separately from starter bar all the way up. So in the construction industry, normally you will use C, type C version. A and B, unlikely, but I will not exclude the possibility of having this kind of design, but very rare. Mostly is type C. So now I'm going to show you a clip. How can you actually, what if your starter bar and your main bar's rebar type is different? How can you actually set it? And also, how can you actually separate out your starter bar rebar quantity and also your main bar quantity? So all this function is going to be captured in this video clip. So as you see here, I have drawn a column and a pile cap. As you can see here, by default, it will actually generate you out a door bar, which is your starter bar. By default, it will automatically generate you out the door bar for you. So in this case, if you are not using T20 bar type, basically your starter bar and your main bar using different type of bar, how can we actually adjust this? Basically, in our attribute editor, under other attribute, it gives you an options to key in the door bar information, which you as per you see in this video. So you can actually key in your door bar. Not many people know this function, to be honest. Not many people know this function. Normally, what they will do is this. They will actually draw 2 columns. First, to cater this, which is they want to have different bar type. Because we all know that in a single column, yes, you can actually key in 2 different bar type, but in terms of the arrangement of the bar is not up to what we want. So with that said, they actually draw 2 columns. And one more thing is this. Why do they actually draw 2 columns? Why? Because they want to separate out the quantity. So don't worry, I'm going to teach you how, or not to say teach, but to share to you all on how can you actually adjust the bar type for your starter bar and how you're going to separate the quantity out. So as you can see here, I key in the bar type 16T10. So once I'm done, I calculate the column again. And observe closely on the edit rebar, 16T10. So with this function, you're able to actually adjust your bar type for your starter bar. So what about the quantity? How can I actually separate out my door bar quantity with my main bar? So after you calculate the whole model, proceed to view quantity by category. Select the particular form, click OK. Select column. Select the set classification condition, because as you can see here, everything is lump. If you want to separate out, you need to go to set classification condition. And then select rebar classification. Select column, select rebar classification. And once you're done, as you can see here, it provides you the range of bars. It actually provides you the range of bars that you can actually show you wish to actually display out in your view quantity by category. And once you're done, make sure you uncheck this thing. Summarize them into main bar link. Uncheck this. This is very important. This is very important. Make sure you uncheck it. Oops, give me a moment. Make sure you uncheck. There's a small row down below. As you can see here, make sure you uncheck this. This is very important. This is the step that is going to help you to separate out your quantity in terms by the main bar, door bar, U-shaped bar, and so on. This is the step. It is very important. Majority people will neglect the steps. So you can actually uncheck that step, uncheck this box, and with that said, your quantity will be separate out based on the bar range. As per this drawing, as you can see here, main bar, door bar, link. The quantity has been separated out. So in this video, we are trying to show you all in terms of how can you actually set different bar type for your door bar, and of course, how do you want to split up your quantity. So next, that will be all for column elements. So those questions are the most common question that will be asked by our clients, basically, which we have compiled and shared to you. Now we're going to move on to beams. So in beams, in our rebar layout, in even of a site label, majority of people are not too sure what does these legs actually stands for. What is the purpose of these legs? So I repeat, this doesn't actually only applies towards your rebar layout. It actually also applies to site label. And two of these methods are the most common used method to actually capture your rebar. So what does legs actually stand for? So basically, number of legs actually represents the number of bottom and top bar. So how many bars you have at the top? Basically, you can key in here, basically. Next, what does this legs actually determine? This leg is going to determine what kind of link design you're going to use. What kind of link design you are going to use. Therefore, many people don't understand the purpose of these legs. And sometimes once they're done calculating their model for the beam element, and they realize this, my link design is wrong. Why? Mostly because of this number of legs. They did not adjust the number of legs, and from that said, this number of legs is going to determine you what kind of link design you're going to use. So basically, software will actually base on this number of legs and actually provide you a pre-input custom link design for you to actually select. So normally users neglect this number of legs, and therefore in terms of the link design and the link quantity is actually wrong. So what if the pre-input custom link design is not what you want? Then you can actually customize it. You can actually customize it by pressing these three dots here. This thing, custom link setting, will actually appear. From here, you can actually customize your link design. Of course, you need to key in the number of main bar, and then which type of links you're going to use, close, open, torso link. And with that said, you can actually use the rectangular and line to actually capture your hook and your links. And once you're done, generate links. And later on, they'll provide you a list. You just make sure you select the correct link that you have created previously. So this is the importance of links. So in terms of if you in the future, if you are doing your modeling, capturing your rebar beam rebar beam quantity, make sure you adjust your links correctly. Okay. So next, this one, oftenly many people ask this question: sloping beam in TRB, can I capture sloping beam? The answer is yes. So the case study is this. It is commonly found that in the construction industry to find a sloping beam with a size of, for example, 330 times 550 / to 1000. How to capture it at TRB? This is where you need to have additional support, or should I say, this kind of beam is normally easily located at beneath a slab, where it's actually require additional support for that slab. Because if it's a high-rise building, it is not, how to say, economical if you use column to support it. So therefore, they will use this kind of beam design to actually support that particular slab. So if you want to capture this kind of design, normally you require to actually use cantilever beam to capture your sloping beam. So what is the difference between a cantilever beam and a frame beam in our software? Now, this is very important. Many people ask this question: what is the difference? And plus, in our beam element, we are unable to have this element for cantilever beam. So how can we actually capture this cantilever beam? So before I will proceed on how to capture it, what is the difference between a cantilever beam and a beam is this. Cantilever beam has one support at one side, whereas a normal beam, both sides must have support. So that's the difference between a cantilever beam and the beam and a frame beam in our software. So cantilever beam has only one support and one side, and normally it's either left or right. But a frame beam, both sides also have support. So that's the difference between it. And other than that, cantilever beam has its own calculation rules. Their rules apply separately with normal frame beam. So if you open up your calculation rule, you're able to realize this. There is actually a cantilever beam rules down below. So in terms of how you want to capture this rebar information for this kind of beam, you can either use site label. And if you were to use site label, it will actually provide you a 3D view rebar. But if you were to capture the rebar in rebar layout, of course, there is no rebar 3D. So how can you actually capture this beam? So this is the basic step. Batch identify support, select and delete one side of the support to actually form a cantilever beam. So this is how you capture a cantilever beam. Because as you can see here, there's only beams and rim beams. So you need to actually apply support, then delete one side of the support to actually make the beam become a cantilever beam. And then how you're going to adjust the size is not through attribute editor, it's actually in your site label. And once you're done, you're able to get the 3D model. So let us see through the video. So firstly, I draw a normal frame beam. And then once I'm done, I'm going to apply support. I'm going to apply support. So you can select batch identify support, select on the beam, right click, click OK. And how do I know that the beam has already applied support? The beam will be in green color, solid green color. I don't understand that sometimes we all get confused between a solid green color and a hash green color beam. Hash green color beam indicates that the beam is already locked and you measure this rebar based on rebar layout. Whereas for the solid beam, it's a beam that you normally use attribute editor or site label, and this beam has already have support. So there's a difference between a solid beam, green color beam, and a hashed green color beam. So the next step you need to do is this. Because I already done batch identify support, the next thing I need to do is actually delete one side of the support to actually form a cantilever beam. So select one side of the support, you'll turn red. As you can see here, you'll turn red. Originally, it's yellow in color. Originally, it's yellow in color. So once you realize that it's already turned red, right click to confirm, click yes. And with that said, Currently, your beam is a cantilever beam. So now you proceed to side label. You proceed to side label, select on the beam, and then you go towards the width and height, and you can do a slash 1,000. And with that said, we have successfully created a sloping beam. We have successfully created a sloping beam. So currently the sloping is actually downwards. What if you want it to be on top? You can actually use our ground beam to actually model it. Basically, currently it's sloping beneath. If you want it to be above, you can use ground beam to model it. The step is exactly the same. So that will be on sloping beam. Now, the next topic I'm going to teach on is PDF drawing in Rebar layout. Often asked question, why? Because normally we only educate our user by using the identify main bar, identify links. But we all know that in construction industry, PDF and scan PDF drawing are commonly used, especially for contractor. So if users receive a scan PDF or PDF beam rebar detail, how to capture it. So this is the sample files that we normally have, JPEG or PDF file. So the things that you need to take note of is this, the type of drawing, scan PDF or PDF file. Both is PDF file, but this is very important because different method, different file type actually apply different method to measure the rebar. So type of PDF file, this PDF file doesn't mean scan PDF or PDF file. This PDF file have another type of meaning which later on I'll touch on. And then the scale of the drawing also very important. So I'm going to touch on scan PDF drawing first, how we're going to capture it. So let me play the video. So basically, in terms of the scan PDF drawing, normally we add drawing at this drawing manager, but this is only applied to CAD drawing or your PDF drawing. But if it's a scan PDF drawing, you require to use picture to actually capture it. You require to use picture to capture it. So in terms of the importation of drawing, is it the same as CAD? Basically, it's the same. So you just click on import. Select on the file you wish to actually import in. Click open, and with that said, you're done importing the drawing in. So the next thing you need to do is this. You need to go and scale it. So basically, you can actually find the scale function, your scale picture basically. You're not going to use this scale CAD because it's not a CAD drawing. So you're going to use this picture scale to actually scale your particular drawing. Select on scale, select on the picture. And once you're done, select 2 points to indicate the distance. So basically from point C, or should I say point B to point C, key the exact value, 1006, click OK. And with that said, your drawing has done scaling. It's up to scale. And now is the fun part. How can we actually identify the main bar? As you can see here, my identify main bar function key is in gray color. I'm unable to click on it. Then with that said, I can't measure my rebar. The answer is no. You can use this function. You can use this function, which is line. You can use line function to capture it. So how you're going to do it is key in the information here at rebar info, select the type of bar. So I key in 2T12, select the type of bar, and then I just have to draw overdraw it. So should I say color it, color the rebar. So as you can see, I select one point to another, you turn yellow, and then I continue it towards the end. And with that said, right click, rebar information will pop up. You check whether the rebar info is correct, whether it's top continuous bar. Click confirm, and you're done. So that is how you capture your rebar for your scan PDF drawing. Next, links. So links is a little bit complicated than how you identify main bar. It's a little bit complicated, but do bear with me. Just now I say that identify main bar, unable to actually use it in your scan PDF because it's in gray color. But why identify link is not in gray color? Why is it colored? I thought this function only applies to cat. The answer is no. For in terms of links, it actually applies similar function as your cat. But then again, the steps is a little bit different. It's a little bit different. So first of all, you need to right-click 2 times. Straight away right-click 2 times, and then you're able to select the span. So let me repeat again. Basically, after you click on identify link, right-click 2 times, select the span of the where you want to have a link as per the video, and then the confirm link information will actually appear. Before this, if you use cat drawing, right, everything will automatically sync in because you're going to left click to select the link information, then right click to confirm, and then you left click on the beam size, right click to confirm. Then all the details will actually go into your confirm link information. But due to it is a scanned PDF drawing, there is no cat line. There is no cat line. Therefore, I'm unable to select the rebar information and the beam size information. So the only thing I can do is skip that step. So in order to skip that step, I require to press right click to skip it. So therefore, I right click 2 times to skip rebar information, beam size information. And now I will key manually in this confirm link information. So I key R6-200. And then the amount will automatically generate out based on the spacing and the layout length that we select just now. And next is the width and height of the beam. And after that, basically the things that you need to check is the same as what we do in CAD layer drawing. You need to adjust the cover, we need to adjust the legs, and then once you're done, press OK. And that's how you captured a scanned PDF drawing rebar layout for beam. This is how you capture it. So now, next, what about PDF drawing? Take note, red color indicates very important. Red color indicates very important. Please do take note on this. In PDF drawing, we all know that there's 2 types. One is vector and one is non-vector. So what is the difference between vector and non-vector? Vector drawing, vector PDF drawing is where those drawing consist of CAD layer in it. Consists of CAD layer in it. Again, I repeat, vector PDF drawing consists of CAD layer in it. Whereas non-vector basically is same as your scan PDF drawing. Basically, it's a scan PDF. Basically, it's the same as your scan PDF drawing. So that's the difference between vector and non-vector. In terms of method of identify rebar, very highly depend on what kind of vector or non-vector drawing you receive, because the method is different. The method is totally different already. So this video will share it to you. So as you can see here, in terms of PDF drawing, you can use Drawing Manager to actually import in, click open. And once you're done, we are not going to use the picture scale function to actually capture the scale. Whereas we're going to use scale CAD, we're going to use scale CAD. So highlight all the CAD. Highlight all the CAD. Right click and then select the span from one end to another. Key in the actual value, 450, and click OK. And with that said, you're able to scale it already. And the next thing is this, you're going to identify main bar. So here, this is the tricky part. So if you're using vector drawing, you can actually use this identify main bar to capture it. If you're using a vector drawing, basically, you can use this identify main bar to capture it. But then again, if you were to use non-vector PDF drawing, you can actually use the line function. Line function. So if you use vector, you're going to use identify main bar. If it's non-vector, you're going to use line function. So therefore, I highly recommend to you all to always take note of this. That's why it's in red color. You need to know what kind of PDF drawing you are getting. So with that said, then only you know which method you're going to use to actually capture the main bar. So basically, it's exactly the same. You use line, you key in the information, and then once you're done, you key in the information. You're going to draw a line over on top of your rebar drawings to actually indicate the length. Similar to scan PDF drawing, it is the same. And once you're done, just click confirm. And then in terms of the links, also it's the same. Right click twice, and then select the span, how far you want it to be. And then, of course, the details also require to manually key in. I'm afraid you have to manually key in also in terms of the link information and in terms of the beam size. All these require to actually key in manually. So basically, the step is exactly the same. So I will skip the end part. So in here, I create a table to actually allow you all to have a better understanding of what is the difference between the scanned PDF drawing and the PDF drawing. Method of import drawing, picture. But PDF drawing, depending on whether it's vector or non-vector, you can either use, if it's non-vector, picture. If it's vector, drawing manager. Method of skill drawing, picture, skill drawing for scanned PDF, whereas for PDF drawing, skill CAD. Method of identifying main bar, line function. Again, PDF drawing, depending whether is it vector or non-vector, you're going to use line function or identify main bar. You need to identify that first. And method to switch between drawings. Scan PDF drawing, you require to delete it and then import it again. There is no other way for that. But in terms of PDF drawing, you can switch between your drawings in your drawing manager, like how you do your modeling at your normal model module inside. You just switch between drawings. So these are the four main difference between the drawings that how to say, in terms of these are the four main difference between your scan PDF drawings and your PDF drawing. Okay. So next, the importance of anchorage in beam. Oh, this is a hot question. This is a definitely 100% hot question. Whenever I conduct a basic level training, this is the #1 question and they will ask. So case study. In construction industry, it is common to receive beam rebar layout drawing. In TRB, to identify the main bar quantity, point anchorage is part of the steps. Is it important to capture it? And can I skip this step? So before this, I have really tabulated, for example, 5 often asked questions in terms of anchorage. So I'm going to explain to you all one by one. So in terms of anchorage, conventional method, right? How we understand this anchorage is this net length plus 2 times span length. So in our TRB software, basically the band length is your anchorage, just different terms only, just different terms. So again, I repeat, conventional way how we actually do measure our rebar for beam, net length plus 2 times band length. But in TRB software, we understand the band length is by anchorage. Just the terms is different. Anchorage is equals to your band length is equals to your anchorage. So the next question is this: point anchorage. Point anchorage. Where should I point the anchorage? Normally, you require to point anchorage at both ends of your beam, where there requires support from other element. Whereas it's another beam, whereas it's column. So any location that requires a support requires anchorage. So you can actually point out. What about the T-junction, or should I say the cross, the center of the cross? Do I need to have a point anchorage there? The answer is no. The answer is no. Normally, location that requires a band, you need to point anchorage. So what about the main bar quantity? Because you see this, user A and user B have the same drawing, but then again, the quantity for the, for example, B1 beam is different. And why is it so? Why is it so? It's exactly the same drawing, but then again, the quantity is different. Now, this is the interesting part. Anchorage point is one of the factors that is causing the variance of beam rebar quantity. Why? Where you point the length or point the point for your anchorage, right, is the key, because that will actually affect your net length. That will actually affect your net length. So normally why there is various quantity for your beam rebar quantity is because of this anchorage. Where you point it will affect your net length. You will affect your net length because anchorage is a fixed value based on your floor settings. Where you point it, that will mark your start and your end of your net length of your beam. So therefore, this is why one of the reasons why that you normally find out that your rebar quantity for your user A and user B have a little bit different, mainly due to this anchorage point, the location you point it. So now, where do I set this anchorage value? Actually, you can set it in floor settings. Basically, you can actually set it in floor settings. Next, how to skip pointing anchorage point now? Because some of the users find that this anchorage point is not part of my practice. Can I just skip this? Yes, you can. Just right click to confirm it, then you can skip the step. But every time I have to right click, it's very troublesome. So the second option is this option, anchorage length, and identify by actual length. So where can I find all these steps, which I'm going to show you in this video. But before I go through this video, the first thing you need to do is this. Always observe here, take note. By using distance function in rebar layout, you need to measure the length of the beam rebar to actually check on the accuracy of the drawing for the main bar. The accuracy. Then, Chester, what do you mean by accuracy? So you're saying that the drawing is wrong? No. I just want to check whether your engineer got include your anchorage length in your rebar layout drawing here. Some engineer will actually include your anchorage length in this drawing. Some may not. So yes, they actually include, then definitely you can skip the step. But what if you don't? Now you cannot skip the point anchorage anymore. Why? Because your rebar quantity will be lesser. So which means it's wrong. When you do poundage, you found your beam quantity is a little bit odd, mainly due to this point. So always make sure to use the distance function to measure the beam. Compare with your manual measurement for one beam will do to see whether this engineer actually captured your anchorage length in this drawing. Yes, you can skip it. No, very important to point your anchorage point. Okay, so how do you want to close this point anchorage function completely? So this video will show you how to do it. Proceed to option in your rebar layout. Set this anchorage length identified by TL to identified by actual length. Click OK. With that said, observe, identify main bar, 2T12, right click, select on the main bar, right click. This thing will automatically appear. Without a doubt, automatically appear. So this is how you can actually skip the function completely. Okay. So the next question, or should I say frequently asked question, is this. Typical beam rebar detail. So in contrast, in this case study will be this. It is commonly found beam which share the same beam rebar details, and it is less efficient to actually capture the rebar multiple times on the same rebar details. So basically B1, for example, if it's on your beam layout plan, you have multiple B1. It is very troublesome to keep on identify the same rebar beam again and again and again. And this is very not efficient. Our software want to boost your efficiency. So that if you require to actually capture all B1 again, it is not efficient. And what if B1 and B2 applies the same rebar quantity, or should I say rebar layout? If I have to do it twice, it's double work. It's not efficient at all. So basically, you can use this apply to other beams to actually capture it. Apply to other beam function to actually copy one beam rebar details to another beam. So you can actually use this apply to other beam function. So before I show you the step by step, I need you all to know these types of beam, because in the types of beam here, we in the process of using this apply to other beam function. In terms of apply to other beam function, there's a step required to ask you to select which beam you want to copy to. So these are the three options that normally you have to select one of it. So unidentified beam, beam which has not identified support, normally is in pink color. Next, identified beams, beam which have identified support, which is solid green color. All beams consist of both unidentified and identified beam. So again, unidentified beam, which is beam that has not identified the support, which is in pink color. Identified beam is beam that is already have support and is in solid green color. All beam applies to all beam. So the steps is apply to other beam, select and confirm targeted beam, select all beams, which is these options, and select and confirm beam which apply the same rebar details. So normally user will ask me, why Chester? Why do you select all beams? Why not just select the beams that I want? Because normally, just to be safe, yes, you can do that. No problem at all. But as a human nature, it is best just to select all beams, just to be safe, and definitely it will copy over the beams, the rebar details to the beam that you need. So how are you going to use that function? Basically, first, as you can see here, apply to other beam, select it, select on the beam that you wish to copy first, then select on the beam that you want to copy to, right click, select all beams, click OK. And with that said, you have successfully copy over the beam rebar details. So that is how you can copy a single beam information to another. Does this apply to site label? The answer is yes, apply to site label too. Okay. So now, the next topic we're going to touch on is slab. The next topic we're going to touch on is slab. So I'm going to touch on two types of error that normally user will face it. Confirm will face it. As for those new user, when you do your modeling for your slab rebar, this kind of error will often prompt up. So basically it says, after done pointing slab rebar, user wish to calculate the slab rebar, but the error prompt up, which is commonly found, what does this error actually stands for? So basically this error is actually commonly found, and it's normally due to your slab rebar modeling. And this error actually stands for where your slab rebar unable to detect your slab. Unable to detect your slab. Why? What is this theory behind this? Because it's this. In our software, in terms of the coding, our slab element is our slab rebar's parent entity. Both, if you want to have slab rebar, you must have a slab element. You cannot have only slab rebar without slab. Cannot. If you want to capture slab rebar quantity, you must capture slab. Cannot have only one exist, must have two. Because slab is slab rebar's parent entity. So what is the root cause of this error? Basically is this. User manually draw the slab element. What? Yes, of course, I manually draw the slab element. Why is it wrong? Why will it cause this particular error? It doesn't make sense. So how can I actually solve this issue? You need to zoom in. So for example, this. So let me show you an example. you have a slab and you have another slab. You manually draw it lah. So in terms, if you don't zoom in, right, you won't be able to detect there's a gap in between. And then you just draw the rebar across. This gap will cause you this error. Because why? Like I said, this is due to slab main bar unable to detect the slab. And slab is your slab main bar's parent entity. So what you can do is you just manually extend this slab to close up the gap and recalculate that particular main bar, then you're able to get your quantity. So this is how you solve errors such as this. Fail to arrange slab/rough foundation rebar on slab. So next, calculate fail. Now this is also another interesting error which often found in the market, So how can we actually solve this issue? So before I proceed on how to solve it, this is the case study. Similar to slab main bar. So basically after I done pointing the slab support bar, then you read and then I go and calculate it. But then again, this error prompt out. Without a doubt, it will prompt out this error. Definitely prompt out this error. So guys, errors such as this commonly found in the after you've done your modeling for your slab support bar. And then what does this error actually stand for? You're unable to detect your slab. So again, it applies the same theory as what I have shared here in your slab main bar. What is the theory? Parent entity. So slab is also slab support bar's parent entity. So both require to have each other to coexist. So the root cause is this. The line, which is this one, unable to detect the particular slab. So basically the purple line, originally is purple line, has already surpassed the slab. So then is this, Chester, and I really keen, this is the formula. This is the actual formula. 1/3 of my length of my slab. So if the slab is smaller than the 1/3 of the demarcation of the slab support bar, how can I capture it? The answer is this. You just directly key in the value. How long you want your slab support bar to be, you just directly key in the value and you recalculate it. You recalculate it, and with that said, the error will be cancelled off. You will be able to solve this particular error. So I repeat again. If you receive this error and it's already based on the formula has already preset by the software, but then again the proper color line indicating the slab support bar has already surpassed the slab, just manually key in the actual length of the bar. So for example, it's 500, just directly key in the 500. And with that said, you're able to solve this error prompt. Now next, one of the most iconic question for slab, which is the slab thickening. Oftenly asked question also. This function also applies to your rough foundation. This function also applies to your rough foundation also. So in the future, if you have rough foundation that requires something like this, you can use this function also. So case study. In construction industry, we often find this kind of slab design, mostly in drop area, which is the thickening, how to capture it. So before I teach you how to capture it, things to take note are, you require to actually adjust the elevation of the slab to actually form a drop first before setting the variable section. Because normally user will straight away jump to the set variable section and try to actually capture this design. But then again, it will not succeed. Why? You need to form a drop first, then only you go to the set variable section to actually form this shape. Okay? And variable section rebar design consists of two types. Refer to calculation rules number 9, which is this one. More than what, less than what, you will follow based on. If it's more, then it will be something like this. If it's less, it will be something like this. In terms of the bar design, and in terms of how much you will extend, it will be something like this. You can actually change it in your section change, drop on top, drop on bottom, how you want your rebar, how much you want your LA to be, so on and so forth. You can actually adjust in these particular rules. So before we talk about rebar, how we can actually form this? So it'll be something like this. Adjust slab drop elevation, set variable section. Select and confirm affected slab and adjust the variable section. So as you can see here, first, always remember to adjust the drop in your elevation. Once you're done adjusting it, you form a drop, select both slab, set variable section, click on it, all side or set multiple sides. What is the difference between these two? Basically, set all side is also how to say, it will detect the side that has already have two slabs combined and requires to form the shape. Whereas the set multiple side is where you can actually select specific location to actually do the variable section. So I will set the first one, okay, and from here, anything in green value, right? In green value, you can actually adjust it. You can actually adjust it. So you can base on your drawing and make adjustment accordingly. So for example, this one, I switch it to 100. On top also, I switch it to 100. Click OK. And with that said, click OK again. And in terms of 3D view, you'll get something like this. So this is how you do slab detailing. Commonly found in the construction industry, to be honest. Commonly found. So the next question, oftenly asked question. Method of measurement for BRC. In TRB, normally okay, let's not talk about the software first. Let's not talk about the software application first. So in our construction industry, how we measure our BRC is normally the net length of net area of our slab. Net area, basically we measure in net area. But in our software, we have two methods. So as you can see here, BRC is measured in two ways, which is area and width, depending on which one you chose. And what is the difference between both of it? So as you can see here in our steel fabric, as we all know that we have these two methods. Normal QS method, traditional method of measurement is by calculating fabric area. By default, it's already there. So there's only a very rare case that some user will need to change it to weight. So what's the difference between these two functions first before we decide which to use? By calculating fabric area, depending on slab area, and by calculating area from weight, depending on how rebar are laid. So what does this actually mean? What does this actually mean? So basically, for example, I have two slabs here. So for my slab number one, maybe I put 1 meter, 1 meter, based on 1 meter, 1 meter. So in terms of this, if it's calculated by fabric area, 1 times 1 is 1 meter square. But in terms of by weight, it will based on the spacing and then divide by the spacing. So net length minus 2 concrete cover divided by the spacing, round out plus 1. That's how our software actually calculate. That's how our software actually calculate. Net length minus 2 concrete cover divided by the spacing, round out plus 1. And then once you've done that, you will actually use this function, method to actually convert from kg to meter square based on this value as per our software, which you can actually set it at your specific rack setting. So now is this. If you add another 1.1 here, 1.1 here, the meter square you calculate, it will be different. But then again, if you add on 1 by 1 here, you divide by the spacing, round out plus 1, and then reversely from kg, you convert it to meter square. The area might be the same, but for this case, this area will not be the same anymore. 1.1 times 1.1. So this is the difference between fabric area and calculating area from weight. So this is the main difference. So depending on how you do your measurement. So I will not say which is correct. This is normally depend on which method you prefer, which method is your normal practice. But based on what I know, in terms of the conventional way of method of measurement for BRC, is normally by calculating fabric area. So that will be all for slab element, which is commonly asked question for slab. So on the final chapter of this workshop, which is wall, layering of wall rebar. Now this is quite often a user will misunderstand and not too sure how to do it. So after user key in RC wall rebar, information for horizontal bar and vertical bar, the software will auto generate a bracket tool in the front. This bracket tool in the front, what does it stand for? So normally user will treat it as this. Hey, this tool, does it mean X and Y? Is it? Because that's the first thing we'll thought of, very common sense. You see the tool, we should think of X and Y. But in attribute editor, we already have vertical information, horizontal vertical bar information. And that is already indicate X and Y. So then what does this tool actually stands for? If it's not X and Y, what does it stand for? Basically, that tool represents the number of rows of bar required for vertical bar and horizontal bar. So this is a cross section. That particular tool actually indicates two rows of bar. One row of T12, another row of T12. So the next question is this: can we adjust the number of rows? So for example, this particular wall only require one row. This particular wall require only one row. Can we adjust it? Yes, you can. And you get something like this. Yes, you can. You just have to key one, and your rebar design will be this. So of course, you can adjust it. Now, next is this binder/link wall rebar. Now, this question, I believe so. Every month, we will at least receive up to 10 questions regarding of this. It is commonly asked question. So in this, so what is the case study? In the construction industry, there is a possibility of engineer will replace horizontal bar with a link or / binder type of a rebar design. Link, you can call it as link, but our software calls it a binder type of rebar design to replica, or should I say replace horizontal bar as per this drawing. So how we capture it? Normally user will go think of, hey, is it adjust in calculation rules? The first thing they will think of is, hey, I think it's calculation rules. No, you need to key in here in your attribute editor. In your attribute editor. So you can actually key in the rebar details for your binder in your attribute editor. So if you're not too sure how to key, there will be a 3 dot at the side there, and will show you how can you actually key in the rebar information for your binder. And why do I say that user will first start off where can we key in the binder value? Is it in calculation rules? Mainly because of this calculation rules, which you can actually find it in your wall rebar, your wall element calculation rules. So in this rule, what do you need to understand? Basically, you need to set whether you want your binder to measure in terms of links design or in terms of lapping, similar to your U-bar, similar to a U-bar, but this U-bar is longer, and there's a lapping here. So you can actually select whether you want it by link or you want it by lapping. And the lap value, you can adjust it through here. So calculated by link, the concept is exactly the same as a normal link with a 24D. Whereas for the calculate by lap horizontal loops is where the loops here allow you to set a lapping at both sides. So basically there's a lapping. There will be a lapping, and then you can actually set the lap here. So In terms of the method of measurement, what does it look like? This is the calculate by length. As you can see here, it's exactly like a length. So in your times the 24D basically. So the concept is exactly the same as a normal length with 24D. And what about the calculated by lap horizontal loops? As you can see here, there is a lapping, like a U-bar basically. So the loop here allows you to set lapping on both sides. So in the future, if you have, for example, leaf core wall that requires to have, they use binder instead of the horizontal bar, you can actually key your binder here, and based on the DQ drawings, what they want in terms of the binder design, which is which, you can actually set in your calculation rule as per here. So now, the next often asked question, additional vertical bar. So case study. Additional bar are often found in RC wall, which normally located at the end of the wall. And T junction, normally we will find this kind of additional vertical bar, which is as shown in this drawing. This is the normal location where you can actually find those additional vertical bar will be placed. And then TRB software consists of two methods to actually input this additional vertical bar. So under which situation users should choose to key in. So which means there's two options, two ways to actually key in the additional vertical bar. Under which circumstances should I use which one to key in? So here I've really shown one of the method, which is calculation rules. The second method, oftenly people will neglect it, which is attribute editor additional vertical bar. This location oftenly neglected by our user. Often, they do not know that they can actually key in the additional vertical bar here. They will always go through here and key in the additional vertical bar here. So now, what is the difference between calculation rules and attribute editor in terms of additional vertical bar? I'll explain to you on the theoretical side on where what is the difference, and in terms of when to use it, it will be highly depending on your drawings and how you want to lay your additional vertical bar. So basically, in calculation rule, if you set here, it basically applies to all wall without a doubt. It will actually applies to all your wall, unless you do it in your attribute editor calculation rule. That is a private attribute. So with that said, that one only applies to your selected, selected wall element. But then again, in attribute editor, it's different. It's only selected to wall, only selected wall entity will take effect on that if you actually key in the additional vertical bar information here. So other than that, if you key in here, you're able to view the Rebar 3D. But if you were to key in attribute editor, I'm afraid you're unable to view the Rebar 3D. And now, in terms of calculation, if you actually key your additional vertical bar here, it has already have a fixed location, which means this tree location. It will guarantee you this, you auto generate you vertical bar at this tree location, without doubt. This tree situation, right, would automatically generate you this so-called additional vertical bar. So the next question is this, because we also face this issue where they will ask us, hey, this tree, right, out of these three options, can I just choose two options to capture this additional vertical bar? The answer is, I'm afraid not. We cannot. It's not separate, it's combined. So how can we solve this? Attribute editor will be the answer for you. You require to use this attribute editor additional vertical bar, because with this function, it provides you the flexibility on which wall you want to set to have additional vertical bar. So based on this difference, you can actually tell which part, which one to use when you want to capture additional vertical bar. So to top up with that, the final difference is this: unable to generate additional vertical bar by using binder for calculation rules. So if you have a scenario where you place your horizontal bar, then I'm afraid that this rule will not take effect. This rule will not take effect. It requires to have horizontal bar, then only this rule will take effect. So if you were to use binder as your horizontal bar, you may need to use this attribute editor to key your additional vertical bar. So that is the 4 main difference between your calculation rules, additional vertical bar, and your attribute editor, additional vertical bar. So you can base on these 4 comparison, and you can actually decide which situation suits you better. So next, after we talk about vertical bar, additional vertical bar, of course, we cannot leave out U-bar. U-bar. Of course, oftenly asked also. So QS often found U-bar in RC wall, where it's located at both ends of the wall. And by this time, instead of U-bar, engineer decide to actually use the band. So in TRB, how can we actually set the band? So by default, our TRB software will auto-generate the U-bar. Confirm. It will automatically generate the U-bar. So in terms of the bar type of for U-bar, you will actually follow your horizontal bar by default. So if your horizontal bar is T10, definitely is T10 your U-bar. So the bar type can be adjusted by directly key in calculation rules. So if you wish to have, for example, your horizontal bar is T10 and your U-bar is T12, you can actually key in here. Again, this one applies to all your walls. This one applies to all your walls if you adjust here. So key here T12, then you can actually set the different bar type comparing to your horizontal wall rebar. And then lastly, in such case that the binder acts as horizontal bar, no U-bar will be generated. So again, this binder, if it acts as your horizontal bar, then I'm afraid similar to additional vertical bar, your U-bar also will not be generated. So so far I haven't actually answered your question in terms of what if I'm not using U-bar, I'm using band. How can I actually solve this issue? So basically, you can actually go into your calculation rules. What you need to adjust is this end of wall and wall to wall, depending on which location you're at. Depending on which location you're at. And then with that said, end of wall. So first you need to do is this. You can actually, based on the condition, which one you're at and adjust it accordingly. So if, for example, if you don't want to have any band, you don't want to have U-bar, you want to have band, sorry, you can actually open up, select on the end, the first option, click on the 3-bar, you can actually switch it to this option. You can actually switch it to this option. And with that said, it will give you band, rather U-bar, rather instead of U-bar. So you can actually switch to this rule. Then what about wall to wall? You can actually, basically this theory applies to outer bar and inner bar basically. So you can actually you can play around with it either on the third one or the fourth one. The top one, 1 and 2 basically have U-bar, but just different condition of on the bar type. But in terms of the if you don't want to have U-bar, it's actually your third and fourth. It's basically your third and fourth. So that is how you can actually set if you do not want to have U-bar. So that is all for our TRB frequently asked question. So if you wish to have more knowledge, or should I say you want to know more on the FAQ or what are the user face issue, you want to learn from them, I highly recommend you all to join this community.clothing.com. Like I said previously, if you require to have any technical assistance, you can always visit us at this Golden e-community, which is we newly launched this year, where there has already have 400 over and constantly increasing every day recorded question, real life user, real life project issue recorded in this platform itself. You can actually filter those questions through here, and you will auto filter. For example, you key column, it will automatically help you to search all column related questions, and you can actually retrieve it. And of course, if those questions doesn't meet your requirement, you can always opt for asking a question. Within 15 minutes, there will be a service personnel, maybe me, maybe my team, will answer you shortly. So I highly recommend you all to actually register to this e-committee. So I'll provide you all 2 minutes time to actually scan for it. So I do hope that you all actually register for it. Okay. So thus, I would like to also introduce to you all, for those who have already update their, or especially upgrade their version to the latest C3 version, you'll realize one thing is that the home page has already changed. So as you can see here, under the e-learning here, the e-learning icon here, we have already input various type of course newly introduced to the market, which is we included this year, which is those intermediate training purposes. So you can actually see here, there's all these four new videos for you all to actually watch it and actually increase your knowledge in terms of our software. How can you actually do the project correctly? For example, pre-contract or post-contract, and if you wish to up your level from basic to intermediate, you can always go through this intermediate TS fundamental to actually increase your knowledge. So of course, if you wish to actually apply for our intermediate cert, do see here, there will be various type of advertisement here, where one of it is the intermediate cert. You can actually click on it. Click on this, it will bring you to that page for you to actually register for the to actually get an intermediate cert. So does this thing only apply to TS? No. In TRB, we will also have the same thing. In TRB, we have two new videos in e-learning. So you can actually up your understanding from basic level TRB knowledge to intermediate and intermediate site label, which I believe a lot of people are keen to actually watch this video and get better understanding on how to use site label to actually measure your beam rebound quantity. So again, here also you're able to visit our, if you wish to actually apply for intermediate cert, you can always click here and then it'll bring you to the page to actually do the registration. Okay. So now we'll proceed to Q&A session. So the first question will be this. Wong Xiu Ying, if we input for additional vertical bar in both calculation rules and attribute editor, will the quantity be duplicated or the attribute editor will take precedence? The answer is yes, it will be duplicated. One of the scenario I can share to you when will you really require to use this additional vertical bar in attribute editor is this. Remember in my slides, one of my slides, so let me bring you back to the slides. our additional vertical bar only applies if you key in calculation rules. For example, if you actually key in calculation rules, it will only apply to this. You will directly apply the additional vertical bar to these three conditions. So what if? So in terms of that, you automatically apply to these three particular design. So when do you need to use this attribute editor is where you have this scenario where you have a single wall, but your your additional vertical bar is different here, 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 here. You want to have flexibility. Then that's the case where you require to use attribute editor. But there's another additional step you need to do. You need to select the wall, right click, proceed to this rule, which is the private attribute editor of this selected wall, set 0 here. Set 0 here. And with that said, then only it will not duplicate your quantity for your additional vertical bar. So again, I repeat, if you key in your calculation rule in terms of the additional vertical bar, you will automatically capture these three conditions. And then if you have a scenario where you have a single wall and you want to have two different types of additional vertical bar, for example, here two, then you require to use this attribute editor. And of course, you need to right click, go to the, you need to go select this wall, go towards the prior attribute of this calculation rule of this wall and set this rule to 0. And with that said, your quantity will not be duplicated 2 times. Okay, so the next question we will have is this. May you teach me, Wong Chuan, how to customize the beam link T12-125 plus 2T12-125. Top bar 15T25, bottom bar 7T12. In terms of beam link, with that said, this one, I'm afraid that you need, if you were to use rebar layout, right, you need to identify the rebar twice. That's the only options you have right now. You need to identify it twice. If you were to use rebar layout, you need to identify it, which means in this step, in this particular step where you need to confirm link, this part, you need to do 2 times. That's the current scenario. You need to do 2 times. Is that okay, Wing Chun? Which means 1 bar at a time. Okay. What about the others? Is there any question? If for those who have no question, please scan this QR code to provide us your feedback. We will really appreciate on your feedback so that we know where we can improve, and of course where I can know what are the things you want to know more in our future workshop. Because in every month we will actually conduct a workshop, so you can actually provide us what are the contents that you wish to know more. Then we might consider it and actually do it in our next workshop. So for those who have no question, please do scan this QR code and provide us your feedback. Is everybody okay, sir? So after 2 times identify, yes. Could you kindly give us an example for what you need? The one is a little bit small the video. Why not do it this way? If you need us an example, you can provide us your drawing and you can actually post this question out in e-committee. From there, we will advise you and provide you a step-by-step how to actually capture these two types of link design. Is it okay? Because I believe if I do it this verbally or especially visually example, it might not have a record for you. But if you do it in e-committee instead, you get yourself registered, you post it up there, there will be a personal answer you shortly. I think that way you can have a record in the future. If you need to refer to it, you can actually refer there. Okay. What about the others? Is there any question on today's topic? Well, you're welcome, Wen Qian. Oh, thank you. Thank you, Sihon Ray. Your support, we really, really appreciate it. So if there's no question, once again, thank you everybody for joining this workshop. Yes, BC Tan, we will share you the recording for sure. We will actually share you the recordings. For those who register, provide us the feedback, we will send you the recordings. Don't worry, we'll send you the recordings. So once again, thank you very much, everybody, for joining me today. I do hope that you all have learned something new or understand better on a certain function. And with that said, stay safe, stay healthy. Hope to see you all in the near future. Thank you very much, everybody.